It's okay.
459. A proton. Oh, okay, fine. Got it. All right, let me share my screen with you. We have done about Bronsted-Lowry acid and bases. Yeah, and even I have told you about the conjugate acid and bases. Yeah, that a strong acid has a weak conjugate base and a weak acid has a strong conjugate base. Yeah.
Yeah.
So, yeah,
Before I just had one quick question.
sure.
Could you draw the Lewis structure for NO3 minus?
Yeah, why not? Just
I
a
just
minute.
wanted to see if I was correct.
Okay, fine. We started a new document, yes. So NO3 minus. Okay. So
Yes.
NO3 minus is this. This is a
All
double
right.
bond.
Okay.
This is a double bond. This is a dative bond. And this is a single covalent bond. When I say double bond, that means double covalent bond, right? And this is a negative charge. And I told you that if something is having a double bond, it will never carry a negative charge. Negative charge would be given to that atom which is singly bonded.
Yeah.
Yes. Yes.
And then in this case, all 5 valence electrons of nitrogen would be used up.
Yes.
Okay. And then one more Lewis structure, N2H2.
All right. This is a you know what? This is the lone pair of nitrogen.
Yeah. Yep.
Okay. Which one? N2,
H2.
N2H2 or N2H4?
N2H2.
N2H2, right. Okay. So N, because you know what? This is NH4, N2, oh, N2H4. Yeah. So
Yep.
N2H2 would be this.
And then they would still have the lone pairs?
Yes, this will have a lone pair. This will also have a lone pair.
Yeah. Okay.
Got it?
Yep.
So these two structures, they have a lone pair, yeah? And
Yep.
when we talk about this structure, that is NO3 negative, then it doesn't have a lone pair.
Yep.
This one. Because this lone pair, so I'm going to rub it because this technically this should not be shown. I'm simply trying to tell you that lone pair has been used up.
Yep.
All right. And this one, this is it. No, N2H2, yeah?
Yep.
Otherwise, you know what? You know what? Have a look. Let me tell you systematically. This is N triple bond N. Got it?
Yeah.
It will help you a lot. This is N triple bond N. That is N2.
Yep.
Okay. Now, if you are going to add one H with nitrogen, that is this structure, look, the triple bond has been changed into a double bond.
Yeah.
The lone pair remains over there. All right.
Mm.
And then this is N2H2. Now, if you want to change it into N2H4, then this double bond has changed into a single bond. And
Yep.
one more H is added. So it's easy to remember like this, right?
Yep.
Good. So now then we talked about Bronsted-Lowry acid and base. We talked about conjugate acid and base. Then we talked about we also solved some questions if you remember, yeah. And then I
Yes.
told you about bases and alkali, and then I told you about amphiprotic species. We did all of them, right?
Would we just
Hmm.
recap a little bit of the Amphiprotic species?
Amphiprotic species. Okay. Yeah, just a minute. Hmm. Oh, oh, This is about alkali. This is amphoteric acid, uh, oxide, basic oxide. We did that. I don't remember where did I do. That I can't see it right now. All right, amphiprotic acid, yeah. So amphiprotic acid, some species can act both as Bronsted lauric acid on a base. We did that because I told you that if the, I think, yeah, this one, if, yes, here it is. I think here it is. Let me label it amphiprotic acids, amphiprotic species. Here it is. Now look, have a look here that this is weak acid. Yeah, we did this. This is weak acid. We know need to remember that HCl, H2SO4, HNO3, they are the strong acid, and acetic acid or ethanoic acid, this one, it's the weak acid. This one, it's the weak acid, right? Now, if I am going to react a weak acid with water, so water would act as a base. It's neutral, but when you are going to react it with the weak acid, so as it is an acid, so water will act as a base. All right.
Yep.
And because ethanoic acid is an acid, so it is going to give hydrogen ion, and that hydrogen ion or H positive will be accepted by water to change into H3O positive. All right. And as ethanoic acid is losing hydrogen as a proton, so that is why this is the conjugate base of the weak acid, that is ethanoic acid. By the way, I have also told you that if the acid is weak, then the conjugate base would be strong. So in this case,
Yep.
water is acting as a base. Now, if I am going to react ammonia with water, which is a very good reaction because ammonia is highly soluble in water, 65,000 times soluble in water.
Yep.
So you know that ammonia is a base. Why ammonia is a base? Because it has a lone pair which it can donate. So if water is going to act with the base, water will act as an acid. So have a look here. Here water is acting as a base and here water is acting as an acid. So it all depends upon the species which is present with water. If with water, weak acid is present, that water will act as a base. If water is going to react with a weak base, then water will act as an acid. Can you see that? Because I said that ammonia is a base because it has a lone pair. So have a look here. Ammonia is going to give this lone pair to water, and water will ammonia will give the lone pair to water, which is acting as a acid. It is acting as an acid, so it is going to give hydrogen ion. Ammonia is going to accept this hydrogen ion by giving the lone pair, and ammonia will change into NH4 positive. And it is an acid. Water is an acid, and you know that acid is a species which gives hydrogen as a proton. So have a look. This is water. This is water. When hydrogen will be given as a proton, what will be left? OH negative, and it is here. So this shows
Yep.
that water at the same time it is acting as an acid or a base depending upon the other species which is present with water. So water is an example of amphiprotic species. Does it make sense?
Yes.
Good, good. So that's it. Now we need to start the next thing. That is, yeah, we have already started it. We were doing
So,
that.
so,
Yeah, yeah.
so basically, an amphiprotic species is something that can act both as an acid and as a base, depending on what it's
Yes.
being reacted with.
Yes,
Okay.
yes. All right. After that, I left the lesson at amphoteric acid. So don't mix them. This is amphiprotic species and amphoteric acid, right? Now, before telling you about the amphoteric acid, I was telling you about the oxides, that there are four types of oxides. Number one, acidic. Number two, basic. Number three, neutral. And number four, amphoteric oxide. Now, we were discussing the acidic oxide, that acidic oxides are being made by non-metals, right? While basic oxides are made by metals. When I gave you the example, I wrote the period three. This is period three. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. I didn't include argon because argon is something which is neutral or which is having the full electron, so it doesn't react. Now, starting off with sodium and magnesium, you know that these are pure metals. When the metals are
Yeah.
pure, they are going to form alkalis or they are going to form basic. So how is it so? Why? Because sodium, which is a pure metal, when it reacts with oxygen, it forms sodium oxide. When sodium oxide is mixed with water, it forms sodium hydroxide. So sodium hydroxide is a very good base, and at the same time, it is a very good alkali. Why do I call it a very good alkali? Because it is soluble in water. So if a base is highly soluble in water, it makes a very good alkali. Does it make sense?
Yes.
Good. Well done. Now, the other thing is that same goes with magnesium. Same goes with magnesium, where is it? Here. Magnesium reacts with oxygen to form magnesium oxide. When magnesium oxide reacts with water, it forms magnesium hydroxide, right? And magnesium hydroxide is a very good, what? It is a very good alkali. Or it is, no, it is not a very good alkali. It is sparingly soluble in water. So let me write it here. That is Mg plus O2, that would be 2MgO solid. This is solid, this is gas, and this is 2Mg. Now, when this magnesium oxide is dissolved in water, then it is less basic. This is very important what I'm telling you. Magnesium oxide is less basic than sodium oxide and A2O, right? Why is this so? Because when magnesium oxide is dissolved in water, it is sparingly soluble in water. Let me tell you what is the meaning of sparingly soluble. First of all, we use the word insoluble or soluble. Then scientists, they came up with the idea that there is nothing in the world which is insoluble in water. Maybe a very minute amount will be dissolved in water, but still up rather 10 raised to the power minus something will be dissolved in water, but still the 10 raised to the power minus something would be minus, that is 0.00000 something, which is a very minute, very, very small amount. But scientists say that there is no species in the world which is not dissolved in water. And if something is dissolved in water up to a very small extent, instead of calling it insoluble, we call it sparingly soluble. Are you getting my point?
Yes.
I think I was not too fast for you.
No, it's all good.
All right. So magnesium oxide, when dissolved in water, it is sparingly soluble in water, and it reacts slowly with water to make magnesium hydroxide. All right. And I'm telling you again and again, it is sparingly soluble. It is sparingly soluble. In some books, it is written as Mg, Mg2 positive or positive 2 plus 2OH negative aqueous. Yeah, but it is sparingly soluble. This is very important, that magnesium oxide is sparingly soluble. How soluble? However, soluble. However, hydroxide is completely soluble. So that is why sodium hydroxide can be called as base and it can be called as alkali, while magnesium hydroxide will only be called as base. It is not called as an alkali. Why? Because it is not greatly soluble in water. Does it make
Water.
sense?
Yeah.
Good. Now, they have given you the reactions, right? And now, one thing more. When I say this is something which I'm telling you in a proper way, because it's not, it is given in the form of bits in your book, right? So when I discuss this group, sorry, this period, that is period 3, and make the oxides, I have shown acidic, basic, and amphoteric. So always keep this thing in mind, that the oxides of the metals, they are basic. When they are basic, that means they will react with acids. This is a very important point. All right, because it is very difficult for the students to remember it without telling that if the oxide is basic and when it dissolves in water, it forms an alkali. So basic oxide will always react with acid. And when it comes to the non-metal, you know that non-metal oxides are acidic in nature. I have made sulfur dioxide, sulfur trioxide, and I told you that when sulfur dioxide or trioxide, they are mixed in water, they form what? Sulfurous acid or sulfuric acid. Are you getting my point, right? Or phosphoric acid or phosphorus acid. You know that these are acids. right? Now, if an oxide is acidic in nature, it is going to react with the base. Does it make sense, Minha?
A little bit.
A little bit. I'm repeating. First of all, have a look here. Sodium and magnesium, these are pure metals. Yes,
Yep.
you know that. When they will react with oxygen, what they are going to form? Sodium
Mm,
oxide.
Yep.
Yes. When sodium oxide is dissolved in water, it forms what? Sodium hydroxide.
Yep.
What does it? What is it? Base.
Base. Yep.
Base will react with what?
Acid.
Acid. So here it is. That's what I'm trying to tell you. So sodium oxide can react with an acid, that is HCl, and it is going to form sodium hydroxide plus water. Yeah, all right,
Yep.
to form salt and water. I hope it's clear.
Yep.
Yeah. So, and the other thing is that even sodium hydroxide will react with water, right? For example, so sodium oxide. Have a look here. Just a minute.
Yep.
This should be this should be Cl. Oh dear. This should be NaCl.
Yep.
To NaCl plus, yeah, salt and water. Salt and water, right? You can see it like this. This is water being removed. Yes.
Yep.
And this is NaCl. All right. Okay. So I hope it's clear.
Yep.
All right. And even you can react, for example, I'll give you another example, Na2O plus H2SO4, that is Na2SO4 plus H2O. This is already balanced. There is no need to
Yep.
balance it. All right. So basic oxide, when react with basic oxide like this, they react with acid because they are basic oxide. I'm repeating, they are basic oxides. They are basic.
Yep.
Right? Now, if you are going to react sodium hydroxide with HCl, then it is the same thing. That is, have a look here. This is water and this is NaCl plus H2O. So one and the same thing. Whether you react, whether you react oxide or whether you react hydroxide. Are you getting my point,
Yep.
Meghna? Is it clear now?
Yep.
All right. So that's what I was trying to tell you, that when we have basic oxide, just a minute. Here it is. When we have basic oxide, this one, I'm repeating again and again, this is basic oxide. And when they are basic, then they are going to react with acid. Now comes this thing. All these are going to make the acetic oxide. I showed you how they made an acetic oxide. Can you see this sulfurous acid, sulfuric acid, phosphoric acid, and sulfurous acid,
Yep.
right? So that means that they are going to form acetic oxide. So when acetic oxides are formed, they are going to react with what? They are going to react with base.
Yep.
Yes, and aluminium. Let me highlight it properly. This is very important. Aluminium is an amphoteric oxide. Why? Now, I don't know whether in your syllabus this is the justification is there that why aluminium oxide is an amphoteric oxide. Have they given? No, they haven't given. I don't think so. No, they haven't given. Aluminium oxide. Now that means I can tell you, I can easily tell you because it's in our syllabus, that is CIE syllabus, that why aluminium oxide is an amphoteric oxide. But because it is not in your syllabus, so I'm not going to discuss that, right? So you need
Yep.
to memorize it, that amphoteric oxide, the aluminium oxide, this is aluminium oxide, is an amphoteric oxide. Now, what is the meaning of amphoteric oxide? Amphoteric oxide is an oxide which reacts both with acid and base. Otherwise, here, Minha, have a look. These two will react with only acid. These two
Yep.
basic oxide. These acidic oxide will react with only base. But
Yep.
aluminium oxide will react with acid as well as base. Does it make sense?
Yep.
Good. And one thing more, I told you about this, that sulfur, which is a non-metal, it's written here, when sulfur react with oxygen, it forms sulfur dioxide or sulfur trioxide. Sulfur dioxide, when reacts with H2O, it forms sulfurous acid. However, if you take sulfur trioxide, then SO3, SO3 plus H2O, that makes up H2SO4, which is called as sulfuric acid. Are you getting my point?
Yep.
All right. Now, coming, because it is given in your syllabus, so that's why I'm covering it. I have written, I think, yes, I have written for the, yes, these are for the basic oxide that they react with acid. And here it is. These are the basic oxide, and I told you how the basic oxide reacts with acid. I have given the reaction for basic oxide and basic hydroxide. Are you getting my point?
Yep.
Basic hydroxide. Now, when we talk about acidic oxide, you know that the oxides of here oxides of here silicon, phosphorus, sulfur, and chlorine. These are what? These are the acidic oxides. So silicon, phosphorus, sulfur, and chlorine, they form acidic oxide. I have told you, bache, I have shown you how they are acidic oxide. Here it is. You can clearly see. Yeah.
Yep.
Can you see? Yes. So this shows that why they are acidic oxide. Now have a look. Now when they react with acid, for example, SO2, when reacts with acid, water, it forms, I have already written it, but I'm writing it again. H2SO3, or SO2 when reacts with SO3 when reacts with water, it forms H2SO4. And they can easily react with what? They can react with, because they are the acidic oxide, so they will react with base. So let me write down the reaction. Although it's not given in your book, but I am sure that they are going to give in the paper, because I have seen that they give less content in the theory, and when they come to the exercise question, they give that content, right?
Yep.
So I'm writing it. As it is an acid oxide, so it is going to react with the base. So sulfur dioxide plus NaOH, it makes up Na2SO3 plus H2O. It's not given in your book, but I'm doing it because I think this is important. Yes. And
Yep.
this is called as sodium sulfite. Sodium sulfide. Now, if you are going to react sulfur trioxide with NaOH, it is going to form Na2SO4 plus H2O. And this is 2 then, because this is 2. So this is sodium sulfate. Okay? All
Yep.
right. So this is for this. And even if you want an extra knowledge, I can give you, that is P4O6. I'm talking about this one. Um, Here, this one. All right. So just for your knowledge, P4O6, when reacts with NaOH, it forms Na3. Now you need to cram it, right? There is no other way of doing it. Okay. So
Yep.
Na3PO3 plus H2O. Now counterbalance. This is, so I need to put 4 here, and then because P is 4, so I need to put 4 here. Are you getting my point? This is
Yes.
P4, so and I need to make P4. So this is P4, and then comes 12 here, 12, and then 6. Yes, it is balanced now. All right.
Yep.
Yeah, it is balanced. Or P4O10 plus 12 NaOH. This will remain the same. 4 Na3PO4 now plus 6H2O. The only difference in these two equations is PO3 and PO4. The rest will remain the same. All right. And why this difference? Because here O is 10 and here O is 6. All right.
Yep.
Now, and now comes the amphoteric oxide, which is given in your book. And I wonder that why they have not given the reactions when they have given you, that is amphoteric oxide. This is very surprising. Are you getting my point?
Yeah.
Because they have given, let me read. Yeah, some species can act both as bronchial lauric acid and base, and after that, when they started this, yeah, on page number, let me tell you, on page number 467, under the nature of science, which is green block, under that, check in the third line. Can you see the word amphoteric?
Yep.
Yeah. So if this word is there, stay assured, Minha, that they in the paper they will give you how aluminium oxide, they will ask rather how aluminium oxide is going to react with an acid or a base, right?
Yep.
So I'm doing it because very much sure that if they have mentioned this word, it means that students should know that how an amphoteric oxide, which is aluminium oxide, how it reacts with an acid or a base. So I'm going to do it right now. Clear? All right.
Yep.
So aluminium oxide. So please, you need to cram them, but do it because it is going to help you. HCl, then it will be AlCl3. You know what? I think I have told you about that. That is, just a minute, listen carefully. Divide it. You can see it can be divided from here or it can be broken down from here, right? Write one here, two here, write one here and two here. Then combine one, two, and two with one. You will get the product. Have a look here. Now, what I am doing, I am combining one with two. So, aluminium will combine with Cl, it will form AlCl3. All right.
Yep.
Then you combine 1 with 2. Then when you combine H with O3, it becomes H2O. All right. So
Yep.
it's easy to remember like this. Now counterbalance it. That would be, if this is 2, so I need to put 2 here. Then it becomes a 6. The Cl would become 6, so I need to put 6 here. And then water would become, hydrogen will be 6, so I need to put 3 here. Are you getting my point?
Yep.
Or should I explain again?
I get it.
Again?
I get it. It's okay.
All right, you got it. Okay, fine. Now, the other thing is this is the reaction with acid. That is, it is going to react with an acid and base. So, this is the reaction with acid. Reaction of aluminium oxide with acid. All right. Now,
Yep.
I will write reaction with base. So, with base, it would be Al2O3 plus NaOH. That would be again. Now you need to, this is somewhat tough. You need to memorize it. That is
Yep.
NaAlO2, 2NaAlO2 plus 2H2. Sodium aluminate. So 2 here. I think it is balanced. Yes, it's balanced now. Yes. This now you need to memorize it, but there is no other way to make it clear,
Yeah.
right? So this one should be memorized and this one should be memorized. But let me tell you that this will definitely be included because the word is included. Have a look here. Oh, they have given. Okay. In yours, they have given with sulfuric acid.
Yep.
All right. And I have done with HCl. All right. So I will write with the sulfuric acid as well. All right.
Yep.
Al2O3 plus H2SO4. So again, in this it can apply. This 1 2 1 2 thing can apply here. Just a
Yep.
minute. Let me stop this alarm.
Yep.
Yes, so Al2O3 plus sulfuric acid, it's given in your syllabus. So this would be Al2SO4 thrice plus 3H2. And for counterbalancing, this is, you can do like this. Al
Yep.
will combine with SO4, yeah, and this will combine to make water, yeah. So
Yep.
this is aluminium sulfate. And then the rest I have taught you, all right?
Yep.
And then they were talking about nitrogen and sulfur. Uh, yeah, here it is. Then, just a minute. Mm, here it is. So nitrogen and sulfur, they are combining sulfur with nitrogen, that they both form the acidic oxide. And by the way, this sulfur dioxide, it is given out by the power stations. Yeah, power
Yep.
stations or industries. And when they combine with water vapors in the air, They form sulfurous acid and sulfuric acid, which contributes to the acid rain.
Yeah.
Clear? Same goes with P4O6. Here it is. All right. It's not given here, but it will become very gross. Otherwise, I will tell you that when phosphorus, have a look here. I will write it because I have done the reaction of sulfur dioxide with water. I'll do it for here. I'll write here. I'll do it with P4O6. P4O6, when combines with water, it forms H3PO3. This is also balanced. This is called as phosphorus acid,
Yeah.
and this also contribute to the acid rain. However, if I take P4O10 plus 6H2O, then it is going to form H3PO4. The balancing remains the same. Have a look. Balancing remains the same. All right,
Yeah.
and this is called as phosphoric acid. So
Yeah.
these are the two acids which are present in the acid rain. Let me tell you this one. Phosphoric acid is in the rain, and sulfurous acid, sulfuric acid, or phosphorus acid. These four acids, they make the rain acid.
Yeah.
All right, clear? All right,
Yeah.
good. So that's about the acid rain, and then they also discuss that the when something, this is something which is very normal, you know about that. I have already discussed it. That if you have a pH scale, this is 0, this is 14, this is sorry, this is 7, this is 0, this is 14. As basicity increases to this side, and acidity increases to this side. When it
Yeah.
increases to this side, that means if something is having the pH, this is pH scale. When something is having a pH 1, that it means it is very acidic. All right. And when in case of base, if something is having 13 pH, we are going to call it very basic or alkaline. All right. So this works in contradiction. That is, the pH of, if pH is very low, then it is highly acidic. If pH is very high, then it is highly basic. I hope it's clear. Yeah. Now that's it. Is it clear?
Yes.
All right. Now the whole discussion would be on the pH scale. P is small and H is capital. Yeah. So this is called as, P stands for power, H stands for hydrogen ions. So pH means power of hydrogen ions.
Yeah.
So when I say power of hydrogen ions, that means we are talking in terms of how acidic something is. So actually, something is. So actually, pH tells us about how acidic something is. All right. So this is for something is. So this is for acidic things, right? For basic things, I don't know whether it's there in your syllabus or not, but I'm telling you because it will make your work very easy. That is, definitely you will think that if something is acidic, we measure it through pH scale. What about if something is basic? Then we have POH, power of hydroxide ion. Is it clear?
Yeah.
All right. And there is a formula which is going to help you in any way, that is pH plus POH is equal to 14. All right. Why? Why is this so? This, you can cram this formula, or I'll tell you why. Because you know what? Power of hydrogen ions. So in water, is neutral. Are you
Yeah.
getting my point? Water is neutral. I'm teaching you this thing, Minha, because I think this is very important, right?
Yeah.
So
Yeah.
water is made up of hydrogen ion and hydroxyl ion. Whenever I write water, I ask you to write it like this, which will be easier for you to understand. Yes. So
Yeah.
this means here you can calculate pH, and here you can calculate POH. All right. Now we say that in neutral water, the hydrogen ions are 1 into 10 raised to the power minus 7. And in neutral water, the hydroxyl ions are also 1 into 10 raised to the power minus 7. All right. We are doing the question as well. It is going to come anyway when we go further along, right? Now, are you getting what did I tell you?
Yep.
All right, good. Now comes the formula. First, I told you that pH is actually the power of hydrogen ion. Now comes the formula. Formula is pH is equal to minus log to the base 10 concentration of hydrogen ions. This is the formula of pH, right?
Yeah.
That is number one. Number two is always the log would be with the base 10. This
Yeah.
is the sign for concentration, which is given in mole per decimeter cube. However,
Yep.
let me tell you whether it is mentioned in your book or not, but this is very important that this formula is used for very strong acids. Never use this formula for a weak acid.
Okay.
Okay, so this formula is only for the strong acid like HCl, like HNO3, like H2SO4. But we will never use this formula for acetic acid, that is CH3COOH.
Okay. Okay.
Cross. Tick,
Is
tick,
that the
tick.
only weak acid?
Yes, it is not used for a weak acid.
So is CH3COH the only weak acid that we
It's
know?
we it is one of the weak I think in your syllabus only an ethanoic acid has been given as a weak acid. So the carboxylic acids are the weak acid. What do I mean by this? That means ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, hexanoic acid. These are the weak acids.
Yep. Okay.
All right, carboxylic acid. I'm talking about carboxylic acid, not only ethanoic acid. Ethanoic acid is the carboxylic acid. All right, so
Yep.
all carboxylic acids, they are the weak acid. Are you getting my point?
Yep.
Right? All right. Now I was telling you about this formula, right? Now have a look. I wrote that pH is equal to minus log of hydrogen ions. Now, if I put this value in it, have a look. pH is equal to minus log to the power 10 and hydroxide ion is 1 into 10 raised to the power minus 7. Take the value, put it in the calculator and you will get the form answer 7. You can do it right now.
Okay. 1 times 10 to the power negative 7.
Log, minus log.
Yep. 7.
Yes, got it?
Yep.
Now, what did I tell you? That in a neutral water, the hydroxide ion are also 1 into 10 raised to the power minus 7. Yeah. So I will apply
Yes.
the other formula. POH is equal to minus log to the base 10 of the concentration of hydroxide ion. Now put it in it. Minus log to the 10 and the concentration of hydroxide ion is what? 1 into 10 raised to the power minus 7. Put the value and you are going to get 1 into 10 raised to the power minus 7. You are again going to get 7. Yes? So
Yep.
POH will also be 7. Now add them up. pH plus POH is equal to 7 plus 7, 14.
Yep.
Is it proved? This formula.
Yep.
Have a look here.
Yep.
Clear?
Yep.
Yes, well done, well done. So this is it, right? Now comes in in your book they have given another one which is like pH. Let me write it. pH is equal to minus log of the concentration of hydrogen ion, power 10, base 10, right? Now, if in any question instead of calculating the pH, they ask you to calculate the hydrogen ions. So the formula would be like hydrogen ions would be 10 raised to the power minus pH. So if they will ask you the hydrogen ions, Minha, they will give you pH.
Okay.
So you will simply take 10 raised to the power minus whatever the value of pH. You are going to get the answer. All right. So if they are going to ask hydrogen ions, all right, if they will give, let's suppose if they are giving you a formula pH is equal to minus log hydrogen ions, whether they need to give you the value of hydrogen ions, then you can calculate pH. Now, if instead of giving the hydrogen ion, they are asking for hydrogen ion, then they will definitely give you a value of pH and then you will apply this formula to find hydrogen ions.
Yep.
Got it?
Yep.
Oh, good. So that's about it. Now, they have given a question. A strong acid has the concentration of hydrogen ions 0.1. What is the pH of the acid? 0.1 mole per decimeter cube. So you will put the formula pH is equal to minus log of hydrogen ions. Now pH is equal to base 10 minus log to the base 10. Hydrogen ions are given as 0.1. Put the value 0.1 here, take minus log, and you will tell me the answer. You can easily tell me the answer.
Is it -1?
Minus 1 or 1? Minus log. You need to take the minus log.
1.
1. So, or they can give the question. I'm making an amendment. An acid. Now have a look. An acid has the concentration of this. What is the pH of an acid? And also tell whether it's a weak acid or a weak acid or a strong acid. And also tell about the nature of the acid.
So
All
this
right.
would be a strong acid?
Yes, because the pH is 1, here it is. pH is 1, so it is very strong acid. Yeah,
Yep.
I hope it's clear.
Yes.
Good. Now, they have also told you. Now, one thing more. Have you noticed that I'm not writing any unit with the pH?
Yep.
Number one, there is no unit for the pH. And you do you remember? First, you told me -1, then I said you need to take a minus log, and then you said okay, it's 1. All right.
Yep.
So that means that you need to take the pH is always given with a positive number.
Yep.
So pH is always positive. It has no units, and pH is always positive. So that means if you are getting a negative answer for pH or pOH, that means you forgot to put this minus.
Yep.
All right. Okay. So let me check from your book now. Yes, Minha, they haven't given this thing. They haven't given this formula, which I think is very important. They haven't given this formula, which I think is very important. That is for the base. How to calculate the pOH. I think you have already got that pH is for acid and pOH is for base. Yes, you know that. Yeah, so this is it. And then pH number is inversely related to hydrogen ions. We have already done that. When we take log to the base 10, when we take minus log to the base 10, that means we are doing inverse of this thing.
Yep.
All right. So what does it mean? What they are trying to tell you? If that they are trying to tell if the concentration of hydrogen ion is very, very high, then pH is low.
Yep.
And that's a strong acid.
Yep.
Are you getting my point? They are trying to tell you
Yes.
this thing, right? So, so the if the concentration of hydrogen ion would be very high, the pH would be very low, right? So that means they are trying to tell you that high hydrogen ions concentration means low pH, and low pH doesn't mean a weak acid; it means a very strong acid,
Yep.
as I told you here. Here. So if something is having a pH of 0 point something or 1 point something, that means it is very acidic. I hope it's
Yep.
clear. Yes?
Yep.
Good. And now they have also written, I have already told you about this. A change of 1 pH unit represent a tenfold change in hydrogen. And that means if, let's suppose they are trying to tell you that if something has a pH 1 and if something has a pH 2, then what does it mean? That if pH has been increased by 1 unit, that means that a tenfold chain in hydrogen ions, right? That this means that the increasing the pH, if you are going to increase the pH by 1 unit, that means that there would be a decrease in hydrogen ion by 10 times.
Yeah, okay.
All right, I'm repeating. Now, look, pH pH 1 is changing into pH 2. Yes, so this is
Yep.
more acidic, this is less acidic.
Yep.
Yes. So what does it mean? It means that increasing the pH by 1 unit, that is from 1 to 2, pH 1 from pH 2, increasing the unit by 1 pH represent a decrease. Definitely there will be a decrease in hydrogen ions by 10 times.
Yeah.
Why? Because I told you that there is an inverse relationship between pH and hydrogen ions. Can you see that?
Yeah.
Minha, something is bothering you, you can ask me, please.
No, no.
Sure. All right. Now they have given a question. They have given that if a pH of a solution is changed from 3 to 5, reduce how the hydrogen ions concentration changes. So that means that pH is 3. So what does it mean? pH is equal to minus log of the concentration of hydrogen ions to
Yep,
power 10. So that pH, you know that pH is the inverse of hydrogen ions. You know that, na?
yep,
So that means pH is equal to minus log to the base 10, and hydrogen ion would be 10 raised to the power minus 3.
yep,
Is it clear? Yes, that is
yes,
fine. Because there is, I will write, there is an inverse relationship between pH and hydrogen ions. If one thing is low, the other would be high. If the first thing is high, the other one would be low.
yep,
I hope it's clear. All
yep,
right. So now, in other words, we can say that if we are going to plot the graph, now whatever I wanted to tell you extra, I have told you, right? So now I am going to stick to the book because the extra knowledge I wanted to give you, I have already given. Yeah. So
yep,
if you are going to draw, oh sorry, if you are going to draw a graph between pH and hydrogen ion, what did I tell you? High, low pH means high hydrogen ions. Yes.
yep,
So that means that there would be inverse logarithm that would be like this.
yep,
I hope it's clear. Yes. Okay, good.
yes,
So now they have given you they have given a table in which they have written the pH of different things. So that was just for your knowledge, right? There is no need to memorize it. Yes.
yep.
What was the page, by the way, Minha? Four something?
468.
All right, just a minute. 468. Just a minute. Okay. Yeah, yeah, got it. Yes. So they have given a table. Let me check. Just a minute. Let me check. Okay, fine. Yes. Now they have given you a table. Can you see the table on page number 470? Yeah. So there is an arrow which is given with red and blue. You know that. I think you know about it, that acid turns blue litmus paper red. Do you know about this?
No,
No?
no,
Oh, okay, fine. Let me tell you this. There are you haven't done this experiment in the lab. There are two types of litmus papers. Uh, red litmus paper and blue litmus paper. No?
no.
Okay, it's okay. I'll tell you. There is a blue litmus paper and red litmus paper. The litmus papers are of two types. Litmus paper are of two types, right? They are made with a dye. That's a special paper like filter paper, and then you dip it in a dye of red color and blue color. And the origin of the dye is marine weeds. Yeah. So if you are going to put a red litmus paper in an alkali like sodium hydroxide, yeah,
Yep.
this would turn blue. The red paper would
Oh,
turn blue. Yes. All right.
okay, okay, yep,
Yeah, I hope you got it right.
yep,
The rest would be red. It depends on the extent to which you dip it in the alkali. Are you
yep,
getting my point? Yeah. So for example, I dipped it till here. I dipped it till here. So it has turned blue. All right. And if I take a blue litmus paper, oh, it will not stay. All right. If I will take a blue litmus paper like this, no, and I dip it in acid till here. This is acid like HCl. Now this will turn red.
yep,
All right. So this is just to give you an idea that litmus paper, there are two types of litmus paper, red litmus paper and blue litmus paper. If you are going to put by the way, if you are going to put red litmus paper in an acid, it will not change color.
Oh, okay.
All right, look, I put red litmus paper in base, then it has changed color. If
Yeah,
instead of taking a base, if let's suppose I take HCl and I put it in, then the color will not change.
yeah,
Same goes with the base. For example, this is a blue litmus paper. I have put it in an acid. So that's why blue litmus paper would change red. However, if I take a base here, then blue color will not change.
yeah,
All right. Now,
yep,
you know what? Now some interesting facts because it is written in your book. If you check the arrow, double-headed arrow on page 470, and then if you check the top side is basic. I will use this simple thing. This is end, right? And this is the lower end.
yep,
And this is 7, neutral, green,
yep,
7. This is uh, a- when you go up, alkalinity increases. All right. And when you go down, acidity increases.
yep,
So this thing, bitter, is the most acidic. This point, that means 0. And this is 14, that is the most basic.
yep,
Okay, now let me tell you one interesting fact. If you check the top corner, you will come to know that milk of magnesia having the pH around. So I have already written this neutral and most basic and most acidic. Milk of magnesia. Can you locate milk of magnesia towards the top right corner?
yep,
Yeah, milk of magnesia is basically magnesium hydroxide. If somebody is suffering from acidity, right? So doctors, they ask them to take milk of magnesia before taking the meal. Why? Because milk of magnesia is basic. So what does it do? It neutralizes the acidity of the stomach.
yep,
So that is why milk of magnesia is taken. However, most of the cleaning agents, they are base. Now they could be shampoo, this could be soap, it could be any type of cleaner. They all contain base.
yep,
All right. And the base feels slippery. That is why shampoo and soap, they are slippery because bases are slippery.
yep,
All right. And while as far as the all the acids, now these are the man-made things, right? Now let me tell you that as God or Allah has made acid naturally in our body, that is
yep,
dilute HCl is present in stomach. Do you know that?
yep,
Because it is important as dilute HCl actually does what it helps in digestion of food, right? So in order to make the food very simple and easy and easy to easy to be digested, then we use dilute HCl. However, one more thing, that all the citrus fruit like lemon, like curd, like what like this definitely curd is not a fruit, just I'm putting all of them together, and like lemon or grapefruit, all right, kiwi, they
yep,
all are acidic in nature. And curd, milk, they are also acidic in nature because milk contains lactic acid, right? So, and grapefruit and lemon, they contain citric acid. That is why they are called as citrus fruit. So, this citrus has been taken from citric acid. Okay.
yep,
So that's it. After that, they have given measuring pH, that how pH is measured. Now, you know what? You can simply put, there is another way. First, I told you about the litmus paper. I don't know whether they have mentioned it or not, but in order to measure pH, I'll tell you variety of things. Measuring pH. pH is measured. And one thing more, Minha, I only told you the things which are important for you, right?
yeah, yeah,
That is going to help you in the paper, right? Measuring pH. pH can be measured. I'll tell you 3 ways. pH can be measured through litmus paper, but that's a rough idea because litmus paper doesn't have the graduations. Yeah. Number two, it can be measured with pH meter. This is the
Yeah.
best way to measure the pH. Number three, indicators.
Yeah.
Now, again, indicators are different types. And the fourth one is pH paper. It's of
Yep.
yellow color. All right. It's of yellow color and it changes color when something acidic or basic is put into it. Let me tell you, if you check on page number 471, top right corner, you can see a figure 5.8. That is for pH meter.
Yep.
All right. So this is for pH meter. Litmus paper, I have already told you, indicators are of different colors. And can you see the indicators in the test tube?
Yep.
All right. So, and pH paper is actually a yellow. Let me check whether it is given in your book or not. No, it's not given. You can search it on the internet afterwards. Just write pH paper and you will see a yellow paper. All right.
Yep.
And that yellow paper can be used to check the pH. The color will change. For example, if you put that yellow paper in acid, it will turn red. If you are
Yep.
going to put that pH yellow paper, a pH paper of yellow color in a base, it will turn purple or blue. Okay.
Yep.
And that's it. And on the next page, can you see pH calculations? We have done some calculations of pH. I will do it again with you. On page number 472, top pictures of flowers. They are actually the dyes to make the red litmus paper and blue litmus paper and the indicators.
Yep.
All right. And then they can, you can, it's also written that this gives a different color. These flowers, they give a different color in different pH. The same flower can be seen as purple or pink or blue, depending upon the pH of the water being used. All right.
Yep.
All right. Now, the examples. Now, if a question is, we have already done that, but still, should we do an example
Oh, yeah.
or an exercise question?
I don't mind.
All right, fine. So if the pH is given at 7.40, human blood, can you don't look at the solution. I'll simply tell you how to do it. I'm just telling you about the question. Human blood has a pH of 7.40. Calculate the concentration of hydrogen ions, right? So what is given? pH
So
of
the
a human
pH.
blood 7.40. They are asking you to calculate the hydrogen ions. So pH is equal to minus log to the base 10 of the concentration of hydrogen ions. Yeah. So this
Yep.
formula, I told you the modification of this formula that H positive would be 10 raised to the power minus pH. Yes.
Yep.
So that would be 10 raised to the power minus 7.40. So you can easily equate it. So the hydrogen
Yep.
ions would be, it is given 4.0 into 10 raised to the power minus 8.
Yeah. I'm getting
Yeah.
3.98 times 10 to the power negative 8.
It's okay,
Yeah.
3.98. That means it will be rounded off. Yeah.
Yeah. Yep.
All right. So this is it. And you must have noticed that hydrogen, if pH is high, pH 7 is really high. Yeah. Now check the hydrogen ions in the power of
Yeah.
minus. So that means if pH is high, then the hydrogen ions are very, very low.
Very low. Yep.
Yeah, so that means a 3
It's
point,
basic.
yeah, 3.98 into 10 raised to the power minus 8 means 1, 2, 3, 4, 5, 6, 7, 8. So that would be 0.0000000398.
Yep.
Such a low value, yeah?
Yep.
I hope it's clear.
Yes.
Anything you want me to repeat again?
No.
It's all clear? All right.
Yes.
Okay. I'm so sorry. I could have given you some extra time, but I have a class scheduled at 4 o'clock, so that's
That's
why.
okay.
All right.
Yep.
Okay. So,
Um,
yeah.
tomorrow's class, can we move it to 9:30 from 9?
From 9 to
Yeah, from
9:30. That means, let me check my schedule. Just a minute.
yep.
Just a minute. Mm, Monday. Okay, that means from 9 to 9:30, 10:30. Okay, all right, fine, fine. I'll ask that girl to change the time. Okay, fine. But that is only for tomorrow?
Yes.
Okay, fine. Fine, Minna. No problem.
Yep.
I'll ask
I'll
her.
confirm it 100% as well, but I can most likely take it on 9:30 tomorrow.
All right. Do tell me beforehand because then I have to change the time of the other student, right? So
Yeah.
if you are confirmed, do tell me. Otherwise, if you are going to take a class, then I'll change her time. Otherwise, I'll keep it as such, right?
Yep. Can I
Yes.
let you know in like an hour before, or do you want to know like way before?
At least 4 5 hours before.
No worries.
All right.
Yep.
Okay. Okay. Okay.
Thank
Thank
you
you, Minna. Welcome, Bitty. Take
so
care.
much. You too.
Lafes.
Allah Hafiz.